This will start a series of videos that we'll do for Math 1110. Now in this course we skip Chapter 1 completely. If you look at the content menu over on the left, the material of Chapter 1 is there, but it assumes that you know most of this, and you can always go back there to look at anything you might have to refresh your mind in. But we don't have any study plan material on Chapter 1. We will start with Chapter 2, Graphs and Functions. And we see a nice little cat here. And what they're saying is the mirror image of the left of the picture. I guess this is the left of the picture, and the right of the picture. Give an example of the cat's face of symmetry. Symmetry is what you see on the left is sort of similar to what you see on the right. We have in human body bilateral symmetry, a right and a left. Starfish, if you ever remember those that have those legs that spread out, look like a star, they have radial symmetry. But we'll be looking at basically the concept of symmetry as we go through a lot of the stuff we're going to be looking at. So we're doing all of the topics in Chapter 2, and there they are listed. So there are 8 topics in Chapter 2 that we cover. We cover a few in 3, in 4, only 1 in 5. So we'll be doing a total of 18 sections in Math 1110. So let's get started. Now we did some of this in Math 1103, the rectangular coordinates and graphs. And here they're giving us some background. Now, throughout this series, I'm not going to read what is in your textbook, but we'll comment on it. Here we're talking about ordered pairs, and you may recall that an ordered pair is a numerical value, and a numerical value, depending on what axes we're dealing with. Here it's the x-axis, here the y-axis, and this can be plotted. Well, in real life, we often can group things together, whether it's scores in a letter grade, number of gallons in a tank with the money it costs to purchase it, expenses, dollars spent in a household, and various things. So our first little topic here, as they give you examples to work on, will be to write ordered pairs to express the relationship between category and the amount spent on it. So we look at our category housing, and this is what was spent on it. And when we put that in an ordered pair, housing, and that was what was spent on it. And then entertainment, and what we spent on it. So this is just a way to take data from everyday life and then convert it, in a sense, to a mathematical expression, in this case an ordered pair. Now, we mentioned above x and y. Sometimes you can have an ordered pair as A and B, which we used in our Math 1103. where this would be the x and that would be the y. Well, you could also have it as C and D, where in a sense the A, being the first item in your ordered pair, is equal to the C, or reflects the C, and B and D the same way. Okay, so here they introduce the rectangular coordinate system, sometimes referred to as the Cartesian coordinate system, named after one of the co-inventors, René Descartes. And it's a way to take these ordered pairs and put them on a rectangular coordinate field. When you make your number lines for your axes, the horizontal is the x-axis, the vertical the y-axis, divides them into 4 quadrants, and there are various characteristics about these. And there is a method to plot them. If you have an ordered pair, for instance, 3, 4, 3 is your x coordinate, so you start at 0, which is the origin where the 2 lines meet, go to the right because it's positive, and then you go up 4 on the y-axis, and there's your point. Now, from this gives rise to something that's called the distance formula. And the distance formula, by definition, and they give you some of the mathematical way of figuring things out, but eventually is boiled down to this formula here. And that is the one you need to be acquainted with. It's a little bit of the Pythagorean theorem. And look, they have a nice little picture of the Frenchman René Descartes. Years ago I used to pronounce that Descartes. Anyway, Descartes. We don't, in French we leave a lot of things out. So, what is the distance formula? Well, if you have 2 ordered pairs, you take the second member of the x value, subtract it from the first, then square that, and the second member of the y set, subtract the first one and square that, add them together, then take the square root of it. Okay? Now you'll be doing practice of these. So one of the formulas you will need to know is the distance formula. Usually they don't put the P and the R there, but that just supposes your points. So the distance between these points is found by having 2 sets of ordered pairs and then putting it in this formula. So they're going to give us an example. And that's the nice thing about the book. Now keep in mind this is also in your practice, in your quiz-mes. So there's the formula. There's your ordered pairs. So for our second ordered pair, which is this one, we'll call this the sub 2's. Our x value is 3. That we'll put there. Now in the formula there is a negative, and our first value then of x sub 1 is a negative 8 that we then put into the formula. Now be careful, and they're giving you this little caution. When you subtract a negative, it becomes a positive. So this becomes 11 here that you will square. And then the same thing here, negative 2 minus, this one is a positive, so the negative applies, a negative 6. So a negative 6 squared is 36, 11 squared is 111. We have the length of the line as the square root of 157. Now that is the length of the line. And that's an exact answer. Let me just mention something. Let's say in another example you got the length of the line was the square root of 12. Well, a technique for simplifying that is to take the 12 and see if there are any perfect square factors in there. And the factors of 12 is actually 4 times 3 is one of them. So you put the 4 under a radical, the part that's not a perfect square under the other radical, and this would become 2, the square root of 3. Where the square root of 12 would be an answer, they may want it in this form, and that's the process of getting it to that form. They're also showing how the Pythagorean theory fits into this, where you have side A, that's squared, plus side B, that's squared, equals side C, that's squared. And this is just a modification of it. Okay. Now, in this example 3, you're going to be using the skill you just worked on, that is the distance formula, and they're giving you 3 sets of points. And on a graph it would look like so. And they're asking you whether these would be the corners of a right triangle. Now we're wondering if this angle right here is a right triangle. You might say, well, how would I prove that? Well, again, using the Pythagorean theory, a squared plus b squared equals c squared. So you're wondering if the length of this line squared plus the length of this line squared is equal to the length of this line squared. And you might say, how in the world would I do that? Well, here they're showing you you would have to do 3 distance formulas, find this distance, square it, and then square this distance and see if in fact it ends up as a right triangle. So you end up with this, which is that, which is true. So this is a right triangle. Now, if you did all of this and found that it didn't meet this criteria up here, you would say it's not a right triangle. So again, this is tedious in that you have to get this one right, this one correct, this one correct, this one correct, and then put it into the Pythagorean theorem. So just this one problem would take quite a bit of time. But again, normally you're not rushed, and it's just a matter of carefully working out it, knowing the principles of what you're doing. Now, here's another definition that they give you, and it's to figure out whether 3 points are collinear, that is, lying on a straight line. 3 points are collinear if the sum of the distance between 2 pairs of points is equal to the distance between the remaining pairs of points. Okay. Again, as long as you understand what's going on, here are your first 2. So you put that in your distance formula, and it comes out to 90. And remember, the square root of 90 is the square root of 9 plus the square root of 10. So this would be 3, the square root of 10. I'm sorry, this is a times here. 9 times 10, there you go. And then you do, well, that was P and Q. Now you're going to do Q and R. Q and R, and that distance is 40. And 40 is the square root of 4 times the square root of 10. And that will be 2, the square root of 10. And that's what they have there. And then you're doing P and this last one. And when you do that, you get 250, which is 25 times 10. Square root of 25 is 5, the square root of 10. And if the 3 plus 2 equal the 5, which is true, we say the 3 points are collinear. Again, each of these examples take quite a bit of computation, careful computation, and knowing this skill. Now, if you had left this at the original, it would be a little harder to figure out. Now, another skill they work on here is called the midpoint formula. So, here's a line from there to there, and you want to find the midpoint, that is, halfway up. Well, this is sort of an easy formula. If you want to find the average distance of your x coordinate, you're going to add your two x coordinates together and then divide by 2. And the same thing for your y coordinates. Add your two y coordinates together and divide by 2. So here is the midpoint formula. Add your two coordinates, divide by 2. Add your two coordinates, divide by 2. And now they'll give you some examples to work. Now as we look at this one, here are our coordinates. We're going to put them in the system, add them up, divide by 2. So this is 2 over 2 when we add these, and we get 1. Then we have a negative 4 and a 1, which leaves us with a negative 3 over 2. So there are the coordinates of the midpoint. Again, rather easy. Now, the next one is a little more challenging. In this case, we know the midpoint and one of the endpoints. What we don't know is the other endpoint. So again, you would use your formula. This would be the point you don't know. This is the one you do know. It is divided by 2, and we know the midpoint is 8. So again, we would clear fractions, multiply both sides by 2. The 2's cancel out on this side, and we get 16. And then we add 6 to both sides, and we get x equals 22. So the missing endpoint of our x value is 22. And here, again, very similar. We know one point of y. There's the other. We're going to divide by 2. And there's the midpoint. So again, we multiply both sides by 2. On this side it cancels out. Here we get a negative 4. Transpose that, we get a negative 16. So our missing y value then is that. Okay, now they're going to ask us to do an application using the midpoint formula. So to do this, you would have to read it carefully. Again, I'm not going to read it for you. If you had a graph, this would be what the graph looks like. You're looking for right there in the middle. And you would use, as we see on the next page, needing to figure what your ordered pairs are. Well, you pick them out from the graph. It's that and that. Again, divide your x's by 2, your y's by 2, and the halfway point is this. Now, again, on these word problems, I'm not going to spend all the time you would have to spend reading it, trying to understand it. We're going over the technique in finding your end results. In this next part, they're just giving you some of the basic background of graphing and checking to see, for instance, is this ordered pair a solution of this equation? So what you would do, this would be your x value, the 1. This is your y value, the 2. You substitute, and notice this side becomes a 0, and it does equal 0. So this is an ordered pair that's a solution of this equation. And now they're going to ask you, for each equation, find at least 3 ordered pairs that are solutions. For all of these, A, B, and C, I would suggest that you set up a t-chart. And then over here, you're going to put values such as a -1, a 0, and a 1. That would be, let's say, for A. Now for B, as you look at this, you might say, what values do you want to have under the radical sign? Well, you want values that make this under the radical sign a perfect square. And this one's a little tricky because you can't have any value underneath this radical sign that would make it a negative number in the end, because there is no square root of a negative value under the radical sign that is a real number. So again, you need to think about that. So your first one might be a positive one. That would be the smallest value, because if y is 1, well, let's see, they switched letters here. They have y is under the radical sign. So y, the smallest value, could be 1. Now, what would be the next one? Well, if y is 5, that would make this a 4, and we can already do that. And then if y is, let's say, 10, this will make this a 9, and the square root of 9 is 3. So again, there's some thinking going on. Now for something like this, a t-chart, whatever values you have for x squared, it really doesn't make any difference. You could have a 0, you could have a 1, and you can have a 2. And that will give you 3 ordered pairs that would be reasonable. So the tricky one here was this one, where under the radical you couldn't have any value for y that would make it less than 0. Alright, let's go on and take a look. And they're giving you some values. Again, it's what we have done. But keep in mind, these are all ordered pairs. And over here, we did those already. And for this one, instead of just having 3, you may need more than 3. So you get enough to make the curve. Okay, now once you get ordered pairs, you then plot them on a graph. And if the equation is linear, you're going to get a straight line. And if that straight line crosses your y-axis right here, this point is called the y-intercept. If it crosses the x-axis, that's called the x-intercept. So now they're going to ask you to graph these equations based on the points that you got. And there's the first. Now there's the second. And again, I know we didn't cover a lot of this in Math 1103 because we only did linear equations. But when you start plotting things like this, again, there's a unique shape that you need to work with and study so that when you do your test, and you'll be doing this in practice and QuizMes, you can recognize what these graphs are like. Now notice this is under the radical sign a -1. So where it starts on the y-axis here is a +1. We're going to see a lot of that where it's like opposite signs. And then this one where it was a -4 parabola, and the y-intercept happens to be -4, and we see that. So you're going to be, as you study these various graphs and plot them, hopefully developing techniques. If you have a graphing calculator, that's going to be useful, but it's my understanding you're not allowed to use that, only the calculator that comes with the program. Now in your online textbook, they do give you exercises, but again, most of your exercises will be done using your practice and study plan. And I strongly advise you to keep good notes of your study plan progress in what might be called a homework log. These would be records of what you've done, areas where you may need more study. You could indicate that by highlighting or some system. And then when you come to Math Lab, you bring those problems in to let the instructor and the tutors help you get a little more information so that you can develop mastery of it. All right, this will wrap up our first one.